So previous topic you guys learned about interference. See, interference confirmed that light is a wave, correct? Where two superposition was happening, dark and bright fringes were coming, and all those things. See, this particular video is about another concept or a phenomenon which confirms that light is a wave. This is what we call as diffraction. Okay. Now, what is diffraction? Now, the formal definition or how we can define diffraction is when the phenomenon in which light encounters an object of its size and enters the geometrical shadow area. This phenomenon is what we call as diffraction. Okay. Now, see, lots of examples we can give for diffraction. Like one simple example is, see, on the bottom part of a CD or DVD, whenever you expose it to light, you'll see all the 7 colors, right? Now, that happens because of diffraction, because there is a very thin layer below that CD, that whatever the plastic disc what you have, that acts like a diffraction grating. Okay, diffraction grating, what it is? It's basically a glass slab with lots of cuts. Okay, in around 10 centimeter glass slab, you'll have around 15,000 cuts. That's basically diffraction grating. So this particular CD, there is a thin layer which acts like a diffraction grating. So that's again a simple example for diffraction. Or even in atmosphere, lots of diffraction will be happening. Okay, now you might have noticed that whenever you see, if there is lots of clouds and if you see the moon, you'll see a halo type of thing around the moon. That is because of diffraction. Okay, so and even the hologram in the credit card or debit card, that works on the principle of diffraction. So lots of examples you see because of diffraction. Okay, the phenomenon called as diffraction. So diffraction is when light enters the geometrical area, the geometrical shadow area. That's what we call as diffraction. Okay. Now there are two types of diffraction: Fresnel diffraction and Fraunhofer diffraction. See, when we talk about Fresnel diffraction, see, this is Fresnel diffraction. Here, the source of light is at a finite distance from the slit. Okay. Now, slit is basically the obstruction, what we can say. Okay. Now, in a Fraunhofer diffraction, the source of light is at infinite distance from the slit. Now, when we say infinite distance, the wavefronts coming from the source will be a planar wavefront. Whereas, for a Fresnel diffraction, the wavefronts coming will be spherical or cylindrical. Okay. Now, in both the diffractions, what we have one thing in common is we have a central maximum. Okay. See, this is the central maximum. Now, central maximum is the brightest part, and if you look at the pattern, as you move away from the central maximum, the width of the fringes is decreasing and the intensity also decreases, correct? So this is true for all the types of diffraction. Okay. So Fresnel diffraction and Fraunhofer diffraction, and very important words are central maximum, and then as we move away from the central maximum, we have first secondary minimum, second secondary minimum, third secondary minimum. Those are all the dark fringes. Okay. Then after the central maximum, we have first secondary maxima, second secondary maxima, like this. That also keeps on going. Okay. So both the types of diffraction, whatever you have, both are important, but for you the most important one is a Fraunhofer diffraction, where the source of light is at infinite distance. In other words, we can say that the wavefronts coming from the source will be planar wavefronts. So you will be studying about Fraunhofer diffraction in the next video.